In this video, we will take a closer look at what is important to consider to successfully deploy a robotic sanding application. Robots are ideal for sanding operations as they provide great consistency and precision. When paired with the right hardware and software tools, the robot's trajectory, speed, and force can be precisely controlled to increase the overall quality of the process and obtain repeatable results. There are many different sanding techniques and tools available, but random orbital sanders are commonly used in the industry because they are efficient, easy to use, and leave less visible scratch patterns or swirl marks due to the randomness of their movement. This guide will mainly focus on them. The first step before deploying a robotic sanding application is to completely analyze the workpiece that needs to be processed. Other than the size and shape, it is important to consider the material composition of it, and if the surfaces are flat, curved, or uneven, as this will dictate the required sanding technique and abrasive media that needs to be used. There is no standard or convention to follow to perform a sanding operation. It all depends on personal preferences, experience, and on the desired surface finish. To better understand what we should consider, let's use the following wooden coffee table as an example. This workpiece has three surfaces that need to be sanded: a horizontal, a vertical, and a curved surface connecting both. Following the manual process to obtain the desired finish, the robot's sanding motion must be parallel to the wood grain at a constant speed of 25 mm per second. It is also important to apply just enough force to let the sanding tool do its job. Too much force will slow down the sander, create scratches, and decrease the life of the abrasive used. For this workpiece, we will need a robot to apply a force of 15 newtons. To ensure that the robot applies the desired force while following the trajectory, it is recommended to use a force-torque sensor. Such a sensor is necessary when there could be some differences between the workpieces and the robot needs to adapt to the surface's contour in real time. Using a force-torque sensor will also ensure distributing the sanding pressure evenly to maintain a level surface. The initial condition of the workpiece will determine what type of abrasives should be used. The roughness of sandpapers and abrasives are rated by a grit number. The higher the grit number, the finer the abrasive will be. To better understand this difference, let's look at a representation of what the cross-section of different grits of sandpaper look like. Remember to always start the sanding process with a coarse enough sandpaper grit to remove the imperfections quickly. Then continue using finer grits to remove the scratches from the previous one used. The final grit will bring the surface to the desired smoothness. There is no fixed rule for how to progress through the grits, but it is important to avoid skipping a grit, as a coarse one could leave deep scratches that successive finer grits might not be able to remove. Keep in mind that different organizations around the world have developed their own grit numbering systems. They all follow a similar convention for classifying the grits in ascending order, with the lowest number being the coarsest and the highest number being the finest. Although the grit number could be the same between the different systems, their roughness will not necessarily be equivalent. Always consider which system your sandpaper manufacturer is using to avoid unwanted results. It is also recommended to use a grit changer for the robot to automatically change the sander's grits, as this will optimize the application's cycle time and avoid the need for the operator to constantly change the grits between sanding operations. It is important to consider how the workpiece will be presented to the robot and how it will be secured. The robot should also be mounted at a position where it will be capable of reaching the complete surface without overstretching, as this could create a high torque on the arm and introduce vibrations that will negatively impact the surface finish and the robot arm. Ensure that the vacuum hose is fully secured and won't become tangled, as this could disconnect it and cause a hazard. If, while sanding the workpiece, any of the robot joints are expected to rotate considerably, it would be advisable to use a spring balancer to hold the vacuum hose rather than secure it around the arm. Regardless of how the vacuum hose is attached, avoid having it pull the arm with great force, as this could negatively affect how the robot follows and conforms to the contour of the surface.